So you have a job you need to get done, but you don't have the designs, but you do have the original parts. Which method do you use to duplicate those parts? You could try 3D scanning, but it can take a lot of time to set up. And sometimes even after all that time, you end up with a dense blob of unusable mesh. I've used just about every method there is out there, but I think there's actually one that's better than the rest in both speed and in accuracy as well. And I think it needs to become more mainstream. So today we're going to test that method. We're going to perfect that method as well. And then we're going to use what we've created to make the parts that we need and assemble them and test them to prove whether or not it translates into reality. So I'll be using the Xtool MetalFab for this work, but if you have a laser or in some cases a 3D printer laser combo with a wide angle lens for part placement, you may be able to do this process as well. If you don't, I also have some other ideas that I'll show you a little bit later on in the video. So these are not being made anymore, and I'm told that the newer options are both cheap and they're flimsy, and because of that, they're actually dangerous to use and they don't last, which is why we're making sets to duplicate this older style. But this video isn't as much about the giant pliers or tongs, it's about how we're going to match them exactly. So let's get this taken apart so we can start to digitize them. Now that we've got this taken apart, the fastest and the easiest thing we can do is take these parts, I have 3 of them, and we can put them directly into the Xtool MetalFab. This should work for any laser or any machine with a wide angle lens up top, but there is also another component. The software needs to flatten that image, which allows us to accurately place our parts. First, I just have a piece of cardboard because the bed is made up of these sawtooth supports. And then I have a piece of neon orange Bristol board in the hopes that it's going to give a really good contrast. So what's going to happen in this case is objects directly below the lens or close to below the lens are going to appear as though they are closer, because they are actually closer. And the objects are at the far corners of the bed will appear as though they're further away. Now, if we were to try and use that image and trace that, we would get nothing close to what we would need. And that's where that flattening process comes into play. It's going to remove as much of that distortion as possible so that we can use it for tracing, or it can be used for part placement. And because there's a correction to the image, we need to plug in the distance from the 0 position of the bed to the top of our parts, because that's where we're going to be measuring to. In our case, I have the cardboard, I have the Bristol board, and a 1/4 inch thick parts. So that's around 9.5 millimeters or about 3/8 of an inch. Okay, and you can see that my image is not quite in the right position here. So I'm just going to move the parts a little bit. So we have the general position, but I don't think this is going to be great for actually trying to trace. And the reason is because we have some shadows here, but I'm going to try the same thing, but this time close the lid, or close the lid at least a little bit. Oh, yeah. Even worse. Big shadows here on the image there, and that's going to make it so it's extremely difficult to use this. There's one more thing we can do. So we've got the wide angle lens up there, but there is another lens right here, and this one here allows us to get real nice and tight and close to our parts. So let's give that one a go. And you pick on the screen your position, so it only does one position at a time. And that's the result. So much more precise area, but unfortunately because of the size of that lens and how close it is, we don't have all of this area. So we're going to need to do it one piece at a time. Now, I already sent an email to Xtool asking them if there's a possibility that we could take several images just at the very beginning in this format, and then it basically would stitch them together and then allow us to trace from there. So let's give this one a go and see how easy it is to trace this part. Made a little bit of a mistake. I forgot to put in my thickness of my part. That includes all of the cardboard and the Bristol board as well. So I'm going to use 9.5 millimeters, and I'm going to take my overall image again. And I'm going to take the close-up shot again. You can see our camera alignment is not quite right. We're off by about 0.5 millimeter. So I think I'd like to scrap this approach and use a little bit different method. When I took those several images and pieced them all together, everything was lining up really nicely. So I do think it's related to the thickness here. One thing to be aware of that I did compensate for was that when you trace it, you're going to be a little bit bigger than what you're supposed to be. Or in the case of the holes are going to be a little bit smaller, but you will still have the center points. So Xtool Studio does have their own offset tool, but I decided to actually export the SVG to bring it into Fusion and just refine it there a little bit. There are some straight sections, which I'm just going to leave. They're good as they are, but there are also some arcs, which right now are drawn as segmented pieces, and I wanted to adjust those into true arcs instead. I have only 2 pieces of steel. I cannot afford to make a mistake here, so I'm going to be using some 22 gauge galvanized offcuts from another project to make sure everything is good to go. These thin parts are insanely fast to cut. The tongs look really good, but I'm off a little bit on the latch for some reason, so I'm going to cut one more with the adjusted thumb trigger to be a little bit larger, and we should be good to go.
And here it looks a little bit off, but that's because there's a big piece of weld that they've ground down right in here. So I did double check this one. We're correct on this one. It was very tempting for me to make both of these the exact same or identical to each other, with the exception of the hole positioning and the amount of holes. The handle has a little bit of a difference in the angle. And then down here at the jaws section, they are a little bit different as well. And I think that might come down to just some wear and tear, or maybe the original templates that they were using to make these were a little bit different as well.
At this point, the max thickness that I've cut with this machine is 3mm thick aluminum, and actually it did an excellent job with that. But we're more than twice as thick, and this is hot rolled mild steel with mill scale still on it. So we need to switch out the nozzle for a 1mm orifice mounted to this extension tube. Now Xtool Studio also recommends that we use oxygen. So I have an oxygen tank and the regulator set up, and the pressure is actually really low at only 8.7 psi needed for these cuts. My tank is pretty small, but it has at least 1500 psi in it right now, so it should last me for quite a while with that pressure. I cut part A and part B, the long pieces of the tongs first, just to make sure that they were good before cutting the rest of the parts. Checked them and then went ahead and made the rest.
And there's our small hole for the spring, nice and close to the edge. That needs to be drilled out to clean that up. So this is what the edge looks like, and it's not sharp. It's not sharp on the top or the bottom, for that matter. It's just a bit of a funny kind of look. Now if you compare it to the original actually has this kind of a look too. So pretty happy with how this turned out for my very first try with 1/4 inch. I'll dial in the settings a little bit more as I go and learn a bit more about this, but I think this will do just fine for this particular job. So this was my very first part, and I've dialed in the settings a little bit more since this point. One thing I did notice is that when the machine is cutting in one direction, it seems to provide a little bit smoother cut, a little bit better result. You can see on this edge here, a nice consistent result here, smooth. But when it was moving in the other direction, it isn't. And I think that comes down to a beam alignment issue, so I've just been trying to get it dialed in right in the center of that nozzle, and also perfectly straight up and down as well. So I think if I can get that, I should get the same results going in both directions. So right here, there's this extra layer of some material. It's maybe an adhesive or something like that. Well, just when it passed over that specific spot, it did not make it all the way through. So definitely when you're machining something like this on a laser, you have to make sure that there are no other foreign materials on the surface, because it will stop that light from being absorbed properly into the metal. So with the parts all finished, I think it'd be a good idea to put a set together to see how it actually works. All the material I was using was 1/4 inch thick. That's the plate that I had. But this part actually is not 1/4 inch thick. It should have been 3/16 of an inch thick. So I did a test. I didn't have much material to test with, and this was the result here. You can see quite consistent. So much better look on the 3/16 of an inch thick, which is 4 millimeters thick. I removed the paint on the top surface because I was afraid that it might not be able to penetrate well through the paint. You see the paint still on the bottom there. Not to mention it does smell when it's cutting, but you can see those oxide colors, so definitely some heat getting into this part as well. So the top camera unfortunately really wasn't crisp enough for what we wanted it for, but the lower camera there, this one did an excellent job and everything was really jiving and lining up perfectly. And it got me thinking a bit about what this reminded me of, and it kind of reminds me of what you'd see on a phone camera. You have these multiple different lenses, and depending on your zoom level or how close you are to an object, it will change the lens automatically. Now, of course, these aren't automatic in the Xtool MetalFab, but it still works on the same basic premise, using the right lens for the right job. I would like to see this technology or something similar or better on every single CNC machine, every 3D printer, and every laser as well. Maybe there are better options out there, but I can't find much right now. I have experimented with a few other ideas to help digitize, like taking a photo from as far away as possible, adding a long ruler for scale, and I fed that into Google Gemini and I asked it to remove any perspective and flatten it to create a template. It did exactly what I asked it to do, but when I brought it into Fusion to compare the templates with the ones that I made, they are not, unfortunately, quite right. I've also used the scanner method in the past, but I haven't used a scanner in years. I don't even think I have one anymore. Someone probably knows how to do this right now, and hopefully they are watching this video. So if you have ideas to be able to implement a system where we can use our camera, flatten the image out, and then trace it, please let me know in the comments down there below. As always, check the links below for products that I've tested and that continue to perform well if you're in the market for a machine like this, or a 3D printer, or a CNC machine as well. And I almost forgot to mention, Xtool was kind enough to provide a discount code for the 1200 watt laser, and that could be the laser itself or the laser combo with the CNC, or they have some other combos on their website as well. I will have links down there below if you're interested in that. Thanks to each of my patrons for helping support this channel and keeping us going strong, and thank you for watching. Take care, and hope to see you on the next one.